Let's see some reactions of sulfuric acid. That is, let's study the chemical properties of sulfuric acid. We know the reaction of a base with an acid. Whenever a base reacts with an acid, it forms salt and water. This reaction is known as neutralization reaction. So our acid, in this case, is sulfuric acid. Whenever it reacts with a base, that is a metallic oxide, it forms the corresponding salt and water. So we see that sulfuric acid reacts with copper oxide to form copper sulfate and water. Similarly, it reacts with iron oxide to form iron sulfate and water. At the same time, the metal hydroxides, they are also bases. So the acid, in this case sulfuric acid, reacts with the metal hydroxides to form the corresponding salts and water. So if we have magnesium hydroxide, it reacts with sulfuric acid to form the corresponding salt magnesium sulfate and it releases water. So a base reacts with an acid to form salt and water. Whenever you see a carbonate or a bicarbonate, be sure that it always releases carbon dioxide gas whenever it reacts with an acid. In this case, we have sodium carbonate and sodium bicarbonate. So when they react with sulfuric acid, they form the corresponding salts, water, and they release carbon dioxide gas. So whenever the carbonates and bicarbonates react with an acid, in this case sulfuric acid, they form the corresponding salts, water, and release carbon dioxide gas. So we can generalize this. We have any carbonate or bicarbonate reacting with sulfuric acid to give the corresponding salt, water, and carbon dioxide gas. Similar is the case with sulfites and bisulfites. Whenever the sulfites and bisulfites react with acids, in this case sulfuric acid, they form the corresponding salts, water, and release sulfur dioxide gas. So the carbonates and bicarbonates, they release carbon dioxide gas. The sulfites and bisulfites release sulfur dioxide gas. So we can generalize this. The sulfites and bisulfites always react with acids, in this case sulfuric acid, to form the corresponding salts, water, and release sulfur dioxide gas. Now let's see the action of dilute sulfuric acid on metals. So when dilute sulfuric acid reacts with metals, we have seen this reaction that there is displacement of hydrogen. So this magnesium displaces hydrogen, it forms the corresponding salt, magnesium sulfate, and hydrogen gas is released. Similarly, zinc, when it reacts with sulfuric acid, hydrogen gas is displaced and it forms the corresponding salt, zinc sulfate. But what happens when these metals react with concentrated sulfuric acid? In that case, when there is concentrated sulfuric acid, so they form the corresponding salts, water, but at the same time, they also release sulfur dioxide gas. The addition of oxygen to any species is known as oxidation. In this case, sulfur is getting oxidized, so concentrated sulfuric acid acts as an oxidizing agent. So whenever metals react with dilute sulfuric acid, they displace hydrogen gas. But when metals react with concentrated sulfuric acid, they form the corresponding salts, water, and they release sulfur dioxide gas. So concentrated sulfuric acid acts as an oxidizing agent. It oxidizes the metals and non-metals. So we have seen the reaction on metals. Let's see how concentrated sulfuric acid reacts with non-metals. So now we have carbon and sulfur. They are non-metals. When they react with concentrated sulfuric acid, we know that concentrated sulfuric acid acts as an oxidizing agent. So in this case, when it reacts with carbon, it oxidizes carbon to form carbon dioxide, it forms water, and at the same time it forms sulfur dioxide. So it acts as an oxidizing agent. Similarly with sulfur, it forms sulfur dioxide and water. So we see that concentrated sulfuric acid acts as an oxidizing agent. So dilute sulfuric acid gives the normal test as all acids. When metals react with dilute acids, they displace hydrogen gas and form the corresponding salts. But when metals react with concentrated sulfuric acid, they give the oxidation products. That is, concentrated sulfuric acid acts as an oxidizing agent. It oxidizes the metals and non-metals. Dilute sulfuric acid acts as an oxidizing agent. Is it true or false? We know that dilute sulfuric acid, it acts as an acid. When a metal reacts with dilute sulfuric acid, it forms the corresponding salt and releases hydrogen gas. So dilute sulfuric acid does not act as an oxidizing agent. So the given statement is false. Concentrated sulfuric acid acts as an oxidizing agent. Another important reaction of concentrated sulfuric acid is that it acts as a dehydrating agent. From dehydrating, we mean that it helps to remove water. So when it reacts with HCOOH, it removes water molecule. So we get carbon monoxide and water. So concentrated sulfuric acid has a very important property. It always tries to remove water molecules. And so it has dehydrating nature. Similarly, when it reacts with C2H5OH, it removes a water molecule in C2H5OH. So now this is ethanol molecule. When water is removed, it forms C2H4, as we can see, and water is formed. So concentrated sulfuric acid acts as a dehydrating substance. It acts as a dehydrating agent. So from dehydrating agents, we mean that it helps in the removal of water. This is a very interesting reaction of a sugar reacting with concentrated sulfuric acid. Observe what happens. So we have sugar or glucose. We add some concentrated sulfuric acid. And then the mixture is thoroughly stirred. So you see that it turns blackish. And then this black substance starts rising out of the beaker. It appears like a snake, which is known as carbon snake. So in this case, concentrated sulfuric acid acts as a dehydrating agent. We take sugar or glucose. So there is removal of water from this glucose by concentrated sulfuric acid. It results in the formation of carbon. This is the black substance that we saw. Carbon is black in color, which appears as a carbon snake. So concentrated sulfuric acid acts as a dehydrating agent in this case. When it reacts with sugar and causes dehydration, that is known as charring of sugar. So in this case, concentrated sulfuric acid is acting as an dehydrating agent. Similarly, if we have a hydrated crystal, for example, copper sulfate crystal, again it removes the water molecules. So it results in the formation of anhydrous copper sulfate and forms water. Another important property of concentrated sulfuric acid is that it is non-volatile in nature. By non-volatile, we mean that it has a very high boiling point of 338 degrees Celsius. This is a very high boiling point, so it cannot easily change into the vapor state. So from a non-volatile or less volatile acid, we can form a more volatile acid. So when a salt reacts with an acid, it forms another salt and another acid. In this case, H2SO4 is less volatile or non-volatile. And that leads to the formation of another acid, that is HCl, which is more volatile. It can easily change into the vapor form. So concentrated sulfuric acid has a property that it is non-volatile in nature. So we have seen that dilute sulfuric acid acts as an acid. That is, when metals react with dilute sulfuric acid, they form the corresponding salt and hydrogen gas is released. But concentrated sulfuric acid, it acts as an oxidizing agent. It oxidizes the metals and non-metals. It acts as a dehydrating agent. It always tries to remove water molecules, and it has a non-volatile nature. So from a non-volatile acid, sulfuric acid, we can prepare a less volatile hydrochloric acid. So these are the properties of dilute and concentrated sulfuric acids.